Welcome. Today's lesson is on 6.1, which is angle measure. Um, the learning target today is really just drawing angles, and you're already familiar with that, but we're going to focus on angles in radians today. So it's not going to seem a whole lot different, but it is quite different than angles in degrees. You will be converting angles back and forth from degrees to radians and vice versa. Coterminal will be possibly new. And then we're going to end with arc length and area of a sector, which kind of ties into some of your geometry background. Okay, so things you should already know. When you draw an angle, your initial side is always the x-axis. So if you look down at these pictures here, the initial side is like your positive x-axis. Terminal side, which is also a ray, is wherever your angle ends. So I drew in a couple random angles, but that dark green line is your terminal side. And then the rotation is the red arrow showing if you're going clockwise or counterclockwise, or maybe you're going around several times. So this one would be maybe, 45-degree angle. This angle going clockwise, of course, is negative. Otherwise, things you're already familiar with, I'm sure, is a complete rotation is 360 degrees, which in radians would be 2 pi. So I'm going to use this as we move on. But remember, when you draw your angle, you start at the positive x-axis and then go counterclockwise if positive and clockwise if negative. Okay, so radian, we have actually been using radian measures for all of chapter 5. So this should be of no surprise to you. However, I don't believe that we've talked heavily about what a radian actually is. So just some information about a radian. I just have some kind of 4 key points down here. Number 1, I think, is the best descriptor. It's the length of an arc that subtends the angle. So if you have the, like the portion of your circumference, here's reminding you circumference is 2 pi r. So if I'm dealing with a unit circle, my radius is 1, right? So if my radius is 1, my circumference is 2 pi. And that's why one rotation, of course, is 2 pi radians. So if you have the length of an arc that subtends the angle, that is this red line here, for example. Of course, it could be different lengths, but that distance, that length is measured in radians. Okay, so number 2 says it's a measure of rotation in terms of pi. So if I did this red line, what portion of pi is that? And you know that pi is over here, and you know pi is 3.14. So this looks like about a third, right? Like this is 1/3. This would be, if I kind of kept picking that up and moving it, this would be 2/3, and then 3/3, and just a sliver more. So it kind of makes sense. So this, where the 1 is, looks like it's about a third of pi, if I were going to approximate it. Okay, number 3 says 1 radian is the distance of 1 radius wrapped on the unit circle. That's actually what I have on this picture. So if I take the radius, which is a length of 1 on a unit circle, and wrap it around, that length is also 1. From 1 to 2, that length is 1, obviously. If I kept wrapping until I got all the way around the circle, I would end at a little over 6. Actually at 6.28, which you know is 2 pi. Just to give you a point of reference, number 4 says 1 radian is 57.3 degrees. So if I actually drew my angle here with my terminal side, that would measure about 57.3 degrees, and you can probably see that okay. So there's just a little background on what a radian is. Converting back and forth should be pretty easy. So in the boxes here, I have how to convert from radian to degrees and then from degrees to radian. If you are going, first box, from radians to, you want your angle to go to radians. That's what blue means. Take your angle in degrees and you multiply by pi over 180. You can technically multiply by any ratio. I could multiply by 2 pi over 360. I could multiply by pi over 2 over 90, but this is the least complicated probably, easiest to deal with. So when you take an angle in degrees and you divide it by 180 degrees, you take yourself out of degrees, right? It's like the degrees cancel out. And then you're multiplying by pi, putting it into radians. Vice versa, if you're in radians and you want to go to degrees, you multiply by the reciprocal of that, so 180 over pi. So a couple quick examples. 260 degrees, I want to rewrite this in radians. So if it's in degrees, I'm going to multiply by pi over 180. Okay, so you can see that setup. And then you can just dump this into your calculator. Normally it'd probably be a non-calculator question. If I cross reduce the 260 and the 180, that's going to reduce to 13 pi over 9. You will have to write your answer as a fraction like that, not as a decimal. So don't just dump that into your calculator and write down the decimal. Guarantee that won't be accepted on WebAssign. If it's a negative angle, same idea. So I'll just kind of go through this one quickly. But negative 340 times pi over 180, converting that to radians, it's just a negative angle, but the same idea. So reduce your 340 over 180 to 17/9. Vice versa, if you're in radians, 15 pi over 2, so no degrees, I'm going to multiply by 180 over pi. And then if you cross reduce, like 2 goes into 180 90 times, so I could go there. The pi's cancel out. So I'm really just left with 15 times 90, which is 1,350 degrees. Last one, 4, and this is radians, right? Because you don't see a degree symbol. Remember, there does not have to be a pi. Pi does not imply that you're in radians. So 4 radians, which is a little beyond pi, right? Because pi is 3.14, so if you're kind of visualizing where that angle is, I'm going to take 4 radians times 180 over pi to put that into degrees. Now this one, you could just leave it as 4 times 180 is 720 over pi. You could just leave that because really, if that's the exact answer, and just to make more sense of that, of course, if you type that into your calculator, it's about 229.2 degrees. So that should be pretty painless, I think. Okay, coterminal angles are exactly what the word says. So co means they are the same. Terminal is the ending side. So the definition of a coterminal angle is an angle that has the same terminal side after rotation. So they start and stop in the same place. So for example, if this is 40 degrees right here, if I go all the way around 360 plus another 40, which would be 400, I would be right back at this red terminal side. So that means 40 degrees and 400 degrees are coterminal. I could also go the opposite direction, start at the initial side, which is the blue ray, and go clockwise, right? And I could go clockwise and end here, which would be negative 320. And how did I get that? I just took 40 degrees and subtracted 360, which would end up at the same red terminal side. So it's probably, I can show you that rotation as well. So starting here at the green, ending at the terminal side is negative 320 degrees. So as of no surprise, if you take any angle and add and subtract 360, you will always land in the same exact terminal position, and they are coterminal angles. The same applies to angles and radians, right? So I can add and subtract 2 pi as well. So you'll be asked to find a positive and a negative angle that's coterminal to the given. So 590, being that's a large angle, if I can add 360, I can subtract 360. It absolutely doesn't matter. There are infinite coterminal angles, right? So I'm going to subtract 360 just because I know I have to get to negative eventually. So 590 minus 360 is 230 degrees. So 590 and 230 are coterminal. That's my positive. Now I need to find a negative angle. So I'm going to just keep subtracting 360, which will bring me to negative 130. So negative 130, 230, and 590 are all coterminal angles. And like I said, I could go on forever. Okay, in radians, it's the same way. So 15 pi over 2, I'm going to add and subtract 2 pi. So I could add, but again, I'm going to subtract because I know I want to get to that negative eventually. So if I subtract 2 pi, now you're kind of dealing with fractions, right? So 2 pi to get a common denominator would be 4 pi over 2. Okay, so 15 halves minus 4 halves would be 11 pi over 2. So there's a positive coterminal. to 15 halves is 11 halves. Now I'm going to keep going until I get negative. So if I subtract another 2 pi, that will bring me to 7 pi over 2. I'm still not negative, so I keep going. Subtract another 4 pi over 2. I'm still not negative, so I subtract another 2 pi, 4 pi over 2, and finally that brings me to negative pi over 2. So 15 halves, 11 halves, and negative pi halves are all coterminal. And these are also coterminal, but the problem was asking for one positive and one negative, so I had to keep going. Obviously, you could do this in one step. Like I showed every subtraction of 2 pi. You get the idea. If you have 4 radians, remember, no degree symbol, so that's 4 radians. Keep in mind now that I would be adding and subtracting 2 pi, but because there's no pi here, I probably want to just convert to decimals so that I can do that subtraction. So if I were to add 2 pi, which is approximately 6.28, then I know 10.28 is coterminal. If I take 4 and I subtract 2 pi, that will bring me to negative 2.28, and I automatically have my positive and negative coterminal angle. So there you have it, coterminals, adding, subtracting 360 or 2 pi. You might be asked to show if 2 angles are coterminal. You can take either angle here and just add or subtract 2 pi to see if you get to the other. So for example, if I start at 35 fourths and I subtract 2 pi, and you know 2 pi as a fourth is 8 pi, that gets me to 27 fourths. Okay, I'm trying to get to 11 fourths. So I'm just going to keep going. So now I'm going to take 27 fourths minus 2 pi, and I'm at 19 fourths. Take 19 fourths minus 2 pi, and I'm at 11 fourths, and that's what this angle is. So that means 35 fourths and 11 fourths are in fact coterminal. If I didn't get to 11 fourths pi, like I just surpassed it, popped over it, obviously they would not be coterminal. So yes, these are. Last but not least, you might be asked to find an angle between 0 and 360 or 2 pi that are coterminal to the given. Okay, so for example, 1560 degrees, huge angle. I want one coterminal angle that's in between 0 and 360. So clearly I have to subtract 360 to get there. So I would subtract 360, and that's still not going to get me in between. So I'm just going to think of multiples of 360. So 360 times 2, 360 times 3, 360 times 4, and I'm going to stop there because if I take 1560 minus 1440, that brings me to 120 degrees, which is in between 0 and 360. So I know that 1560 and 120 are coterminal. So basically, again, you're just subtracting 360, subtracting 360, subtracting 360 until your angle is in between 0 and 360. So with 77 pi over 6, I'm going to keep subtracting 2 pi until I get there. So 2 pi is a 6, of course, would be 12 pi over 6. And then 24 pi over 6 would be twice. 36 pi over 6. 48 pi over 6. So again, just kind of keep going with the 2 pi. And when I finally get down to 72 pi over 6, and so if I take 77 pi minus 72 pi over 6, I get 5 pi over 6, which is in between 0 and 2 pi. So just keep subtracting 360 or 2 pi. Okay, on to arc length. Quick background from geometry. When you did arc length, you were probably given the formulas. So again, visually speaking, arc length is a portion of the circumference. So if I, took a marker and drew this portion right here of the circle in yellow, that is my arc length, okay, a portion of the circumference. So first you have to know the fraction of the circle that you're dealing with. So you'll have some central angle. You can see my red angle here. So let's just say that's, 60 degrees. Well, what portion of the whole circle is 60 degrees? That would be easy to figure out. I would just take 60 degrees divided by, let me go radians. So pi over 3 divided by 2 pi. So pi over 3 divided by 2 pi is pi over 6. or 1/6, excuse me. So that would be a sixth of the circle. And you can kind of tell, like this is 1/6 of the circle, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. If I take the fraction of the circle times the circumference of the circle, obviously the 2 pi's are going to cancel out, and you're going to be left with the angle times the radius. Okay, so arc length, the formula in the box here is what you'll want to write down. Arc length of a circle is denoted by the letter S, by the way. It's your angle times your radius. Now, this is super important. I would highlight this in your notes for sure. I'm going to box this in. Your radian, your angle, your central angle, your central angle needs to be in radians. So if it's in degrees, you need to convert it. Okay, so here's a quick example of arc length. It's pretty easy. I mean, you just dump the stuff into the formula. But we have the city of International Falls and Eden Prairie, and they lie approximately on the same meridian, which is a longitudinal line, if you're not familiar with that. International Falls has a latitude of 48.6 degrees north, and EP is a latitude of 44.9 degrees north. So they're pretty, close. We want to know the distance between the two cities, and we know that the radius is 3,960 miles. Okay, I wouldn't expect you to visualize this. So here's a picture. Here's your equator. You can see where International Falls and Eden Prairie are, well, kind of on this tiny little map, right? Okay, and then again, the radius, so that would be from the center, the middle of our world here, to either of those cities, is 3,960. Okay, so if you can see this tiny little yellow marking, if I go from International Falls to Eden Prairie on the map, it's creating this little arc length, and it's really hard to see because it's tiny, so I apologize. But again, it's an arc length. Like if I just drew a circle around here, it's a little tiny piece of that. Okay, so if I focus on this yellow arc length, I can see that the angle here, this central angle, is tiny. And how do I find that angle? Well, it's the difference between these two, because I know that Eden Prairie is 44. So from the equator to Eden Prairie, this angle is 44, and then International Falls is 48. So if I subtract those two angles, the angle between the cities is 3.7 degrees. Now remember, when you're doing arc length, the angle has to be in radians. So I'm going to do quick conversion. 3.7 degrees times pi over 180. Dump that into my calculator, and I get 0.0646 radians. Okay, don't use degrees. So I know the angle and I know the radius that was given. So now I can just find the arc length. So arc length is angle in radians times the radius, and that gives me 255.7 miles. And if you're familiar with where International Falls is, you can make sense of that. Like, okay, yeah, they are about 255 miles apart. So there's an application for you for arc length. All right, last one then is area of a sector. So if you have a circle and you want to find the area of a sector, I should have drawn another circle here, but well, I can. If you have a circle of any size here, and do you want to find the area of a sector? So you might, if I just kind of draw this, and let's say this is my angle, area of a sector then would be all of this. This is your sector, the area of this region right here. Okay, so again, I have to know the central angle. And if I figure out the fraction of the circle of that, and then because it's area, I'm going to take the fraction of the circle, 0 over 2 pi, theta over 2 pi, angle, times the area of the circle, which is pi r squared. The pi's cancel out, and area of a sector is going to be 1/2 times radius squared times the angle. And again, the angle has to be in radians, so I would highlight that as well. Again, that's the same as sector length. Okay, so you need to know the radius and the angle again. So again, pretty easy. You'll have the formula given. So again, quick example here. Grounds crew for the high school is adjusting the sprinkler heads prior to watering season. One of the large sprinkler heads that waters to the practice fields shoots a stream of water that's 40 feet. The water needs to cover an area of 1,500 square feet. What angle of rotation should the ground crew set the sprinkler head at? Okay, so here's a picture. Here's your field that they're watering, the sprinkler. Okay, so I need to figure out this. What is this angle of rotation so that as this sprinkler moves back and forth and back and forth, it's covering an area, which is going to be a sector area, right? Like if this is your sprinkler here, of 1,500 square feet. Okay, it's shooting a stream of 40, so there's my radius. Okay, so I know the radius is 40. I know the area is 1,500. So if I set that up in the formula, I can actually just find theta. So 40 squared, of course, is 1,600. Half of that is 800. Divide that over, and I get theta to be 1.875. And that's in radians, which is completely fine because remember, your angle is always in radians. But if I told somebody, hey, go set the sprinkler head to 1.875 radians, that wouldn't be helpful because you can guarantee that it's probably measured in degrees. So just to make sense of that, I'm going to convert this radians to degrees. So I'm going to multiply that by 180 over pi, and that sets my angle to 107.4. So that means if I give you a visual here, your there we go. Your sprinkler head would start at the positive x-axis, and then it would just rotate around to 107.4 degrees and rotate back and just keep going back and back. And this area of the field would be 1,500 square feet that's getting watered. And there you have it. That is 6.1. Have a wonderful day.